So in section 2, we're going to talk about what we call rational functions. Basically, rational functions, the way they're made up is it's a quotient, so you're dividing two polynomial functions. So you have a polynomial function on top, and then you have a polynomial function on the bottom. Basically, the big idea is that with rational functions, you're going to have a variable on the bottom. Sometimes on top, but definitely on the bottom. Okay. The domain of a rational, so then if you have a variable on the bottom, then you have the potential of the denominator equaling 0, right? Which is not a possibility. It can't happen. So the domain then of a rational function is all of the numbers which do not make the denominator 0. All right? So in short, rather than saying what the domain can be, normally we just say what it cannot be, and it's, a little bit more efficient. Okay? So we exclude those values for which the denominator is 0. Okay?
So it's like all real numbers.
Right.
But not 0.
Right. The thing about rational functions is many of them have asymptotes. All right, so let's talk about what an asymptote can look like. We've done asymptotes when we did, what was it? Sine and cosine? No, secant and cosecant graphs? Okay. So take a look here. We have some examples. We can have vertical asymptotes, right, which look like this. We've seen those before. We can also have horizontal asymptotes, which are somewhat new this year for us. That's what horizontal asymptotes look like. Now, a few things about vertical and horizontal asymptotes. We've touched on vertical asymptotes before. Vertical asymptotes are like walls, solid walls. They're like a force field that you cannot penetrate. There is no way a graph could cross through a vertical asymptote. No way. All right? Horizontal asymptotes are a bit different. And, I've seen many people misinterpret horizontal asymptotes, but it's very, very important that you understand that horizontal asymptotes take effect only at the edges of a graph. So if you have a horizontal asymptote here, it's very, very possible for a graph to cross the horizontal asymptote in the center of the graph. In fact, it's possible the graph could cross the horizontal asymptote 1,000,000 times as long as in the end it levels off towards the horizontal asymptote. And here too, at the end, it levels off. So the thing is, horizontal asymptotes take effect at the infinities, at the very, very edges of the graph. So in the middle, it could cross as many times as it likes. In the end, that's when it takes effect, and then, the graph will level off. A heartbeat would look like that. Current, alternating current in a circuit with an inductor, with a capacitor, with a resistor will look like that. Okay?
Is there ever a time where it's going to be like it doesn't touch the asymptote or the line?
Yeah, it's possible that it doesn't cross, but it can cross. Whereas the vertical asymptote, not the case. Okay? All right, with that said, how do we find vertical and horizontal asymptotes? Again, one thing to keep in mind is vertical asymptotes and horizontal asymptotes have nothing to do with one another. They're completely independent of one another. Just because something has a vertical asymptote doesn't mean it does or it does not have a horizontal, and vice versa.
They have both.
And the way we find them is independent of one another. So the way to find a vertical asymptote is, first, simplify the function. Okay. Oh, I say that here. Okay, simplify the function. It's so important. I just, that's my spiel. You got to simplify the function. Simplify the function, then find the zeros of the denominator. All right? So simplify then find the zeros of the denominator. So basically, in technical terms, it's the zeros of the factors of the which cannot be eliminated from the denominator. Okay? Okay, hang on. So the horizontal asymptote now, completely different, okay, in how we find it. For the horizontal asymptote, what we're going to do is divide the term with the highest, this should say degree, in the denominator by the term with the highest degree in the numerator. Okay, so basically we're going to be dividing the highest degree from the top, the highest degree from the bottom.
When you divide exponents, subtract.
Yeah, so here it's a lot simpler than that, really. So there are three possibilities. All right, so what we're doing is we're taking the highest degree, the term with the highest degree on top and the bottom. So we're comparing two things. So essentially here, I'm comparing that with that, right? Highest degree, term with the highest degree, term with the highest degree. Essentially what I'm doing is I'm just comparing exponent on the top with exponent on the bottom. So there are three possibilities. One is the top could be a lower number, they could be equal, or the top could be a higher number. Correct? Okay, so let's take the three cases. If the numerator has a lower degree, minimal thinking involved, the horizontal asymptote is just y equals 0. That's it. You should, yeah. In algebra or intermediate, you should have seen it. I teach it here like you haven't seen it before because we all need a refresher. So in this case, I ignore everything other than the degree with the term with the highest degree. So here I have x to the 2, x to the 3. Numerator has a lower degree, so y equals 0 is the horizontal asymptote. That's it. It's just what I said here. If the numerator has a lower degree, then it's just y equals 0. Okay. If the numerator and denominator have the same degree, all right, like this one here, look at this and look at this. They have the same degree. That means essentially the exponents, the variables will cancel out, and the horizontal asymptote is just the simplified fraction. So a horizontal asymptote is y equals -5 over 2. You just take the coefficients. If it needs to be simplified, of course you simplify it.
What about
if they're equal.
the plus 7?
You ignore them, you ignore them, you ignore them. Okay. Then, so the next possibility is if the numerator now has a higher degree, that's even simpler. There's no horizontal asymptote. That's it. Simple. Done.
So what do we write for that one?
You say no horizontal asymptote or none. Okay. Here we go. We're going to find the domain and the vertical and horizontal asymptotes for the following function. So remember what we said about the domain. The domain is all numbers except where denominator equals 0. Okay? Now, it's always good practice okay, so take a look at this. X squared minus 1. Where does the denominator equal 0? So what I do is I take the denominator and I set it equal to 0. So that will be x squared minus 1 equal to 0. Okay? So, that's x minus 1, x plus 1 equal to 0. Yeah, so x is plus or minus 1. Root 1 is 1, right? So, okay, so if x was equal to 1, then 1 minus 1 would be 0. You get 0 in the denominator. So then the domain here would be all real numbers minus plus or minus 1. So now, how do we write all real numbers? There are two ways to write all real numbers. One way is this fancy R. That means all real numbers. Minus, except, in curly brackets, we say what numbers it cannot be, plus or minus 1. All right? So what this is saying is all reals except, plus or minus 1. Okay, so that's the domain.
What if you do like this?
It's very easy. You do just like this is how you write an R, right?
No, I'm talking about this.
Oh, the squiggle. I mean, it's just do the best you can. Okay.
I can't.
Now, for vertical asymptotes, try to do your best squiggly. For vertical asymptotes, again, we're going to set the denominator equal to 0. So what I like to do for vertical asymptotes is factor the numerator and denominator. All right? Now, in the denominator, I have x minus 1, x plus 1. Now, here's the big question. Does anything from the denominator cancel out with the numerator? What do we have in the denominator? X minus 1. Okay, so the x's can't cancel out because it's x minus 1 as an entity, and you don't have an identical one on top. You don't have an x plus 1 on top. Nothing cancels. So, where these equal 0, you have vertical asymptotes. So, x minus 1 equals 0, x equals 1, x plus 1 equals 0, x equals negative 1. So your vertical asymptotes are x equals plus or minus 1. Okay, yes. It's very, very important to note the following. Whatever values you get for vertical asymptote, okay, they must have shown up in your domain. All right? So everything that shows up as a vertical asymptote must have shown up as an exception in your domain. But the logic doesn't go in the opposite direction. Not everything in the domain will necessarily be a vertical asymptote. So all vertical asymptotes come from the domain, but not everything in the domain will end up as a vertical asymptote. It might end up as a removable discontinuity or a whole. We'll talk about that later. All right, let's do horizontal asymptote. For horizontal asymptote, it's important to go to the original function, right? The horizontal asymptote, we're going to go to the original function, not the one we factored. So you go to the original function, term with the highest degree, term with the highest degree. The bottom has more x's. The numerator has a lower degree, so it's just y equals 0. Okay. One more thing. Asymptotes are lines, right? So they have to have an equation of line. So it has to be an equation. X equals something, y equals something. Otherwise, it will be a point off. Okay? All right, so let's do another one here. Same situation. Domain. So essentially for domain, any number is okay as long as when you put it into the denominator for x, the denominator doesn't equal 0. So we have to find the problem points where the denominator will equal 0. So let's see where this denominator equals 0. Should not. Yeah, let's see where it does equal 0, and then we'll exclude those. So 2x squared equals minus 1. X squared equals minus a half. Square root x equals plus or minus what? I something or other. I times 1 over 2. Did we get a real number? No. Does that I show up on our x-axis? No. It's imaginary. That means if the only place that the denominator will equal 0 is an imaginary number, that means there are no real numbers, which makes the denominator 0. All right? Which means there are no problem points. So the domain is all real numbers. All right? So let's look at that logic one more time. For the domain, we want to find points which make the denominator 0 and exclude them. Okay? We just found out there are no points where the denominator equals 0. So all numbers are cool. That means the domain is all real numbers. Okay? So there are no real values which make denominator equal to 0. That means all values work. Okay? All right. For the vertical asymptote, we were supposed to factor, but this can't be factored. And then, okay, so if the domain is all real numbers, there is not going to be a vertical asymptote. So it's none. Vertical asymptote is none. Right? Again, what's vertical asymptote? It's where the denominator equals 0. This denominator never equals 0. So there are none. Okay? So remember what I said is anything that you get as a vertical asymptote must have shown up as a problem point in the domain. We didn't get any problem points in the domain, so no vertical asymptote. Okay? Math is very consistent in that way.
So the horizontal is 4 over 2.
Horizontal, right. We go to the highest degree, same degree. So it's y equals 4 over 2. You must simplify to y equals 2. Y equals 2, yes. Okay, let's do one more. Domain. Set denominator equal to 0. What do you think x equals here? 0. So, is it true that when you plug 0 into the x here, the denominator becomes 0? Yeah. So the domain is all real numbers minus 0. Okay. Vertical asymptote, set the denominator equal to 0. X equals 0. Kind of the same. Everything that's a vertical must come from the domain, but not the other way around. Okay, horizontal asymptote.
It would be none.
Oh yeah, y equals 0.
Y equals 0. If there is less on top, y equals 0. Correct. Okay? Yes.
So essentially, the vertical asymptote is just the factor version of
Yeah. Yeah. Okay, now let's graph them. Do you remember when to graph something like this, you had to reach for your calculator? No longer. No longer. Okay, so we're going to graph this. To do that, though, first we have to do domain, asymptotes, and then we're going to go a step further than that. Okay. Let's do domain. We set x squared minus 4 equal to 0. You know what? Let's factor this guy first. We're going to end up doing it anyway. It's x plus 1, x minus 2, x plus 2. Is that right? Now, just by looking at this, can you tell where the denominator is going to be 0 just by looking at the factored form? Plus or minus 2. So, you know, that's good enough. So the domain is all reals minus plus or minus 2. Okay. All right, what about vertical asymptote? Just x equals 2? Why not negative 2?
Plus and minus 2.
Both of them. So x minus 2 doesn't cancel with anything on top. X plus 2 doesn't cancel with anything on top. Both of those give you vertical asymptotes. So it's x equals plus or minus 2. And you know what? I'm going to go ahead and plot that right now so I don't forget later. Okay. For horizontal asymptotes, I go to the original function, x over x squared. What do you think? Y equals what?
0.
Y equals 0. Here. Okay, so if you're using a pencil on the test or quiz, let's say. So, yeah, well, and like you see what I did here? I do it like a hair above the x-axis so it's visible. You have to make sure that asymptote is visible, because if there is any doubt that you've shown your asymptote, you know, then I won't give you the points for that. When I grade something like this, I write up the solution and then I award points for each part. So I'll say, okay, 1 point for this asymptote, you know, 1 point for each of these asymptotes, and so on and so forth. Okay. Next. To graph this, we're gonna go one step further, right? Because now it's just an open field. We need some like specific points. We're gonna go one step further, and what we're gonna do is we're gonna find the zeros of this function. Remember, the zeros of the function are where the graph crosses the x-axis. To find it off of a rational function, all you have to do is set the numerator equal to 0 this time. The numerator equal to 0. So that's x plus 1 equal to 0. X equals negative 1. Okay. Now, let's think about this for a minute. Okay. Now I need to, I pretty much have 99% of the information I need to graph this. Okay. Believe it or not, it's a lot easier than you might think. So let's think about this for a minute. I know that in this center section here, the graph crosses the x-axis right there. I also know that I have 2 vertical asymptotes on either side. So it's got to follow a vertical asymptote on top, and it's got to follow a vertical asymptote on the bottom. But it can only cross the x-axis at that one point. So what are some possibilities? One possibility is it looks like that. Is that right?
Yeah.
Is there another possibility? The opposite direction.
Yeah.
Does it matter?
The opposite direction. Well, yes, one is right, one is wrong. Okay? So now, but we can figure it out. Okay? We can figure it out. So, but there is no other configuration, right? We're clear on that, because it can't cross the x-axis in any other place. And we know it's got to follow the asymptote on top. It's got to follow an asymptote on the bottom. So how do we figure out which way it goes? We choose a test point. I love this because it's like a little, like a mystery clue game, right? Choose a test point. Yeah, it does look like a chromosome. All right, let's choose x equals 0 because that's my favorite number, 0, except when it's a grade. Then I don't like 0. Okay, so we're going to put 0 into this function, into the original function. F of 0 is 0 plus 1 over 0 minus 4. So 1 over negative 4. Okay? So that means When x is 0, y is negative 1/4. Does that narrow down the possibilities for us?
Yeah.
It sure does. So it's this one. Okay?
Looks like a tangent graph.
Yeah.
Yeah, but it has nothing to do with it. It just has the same shape. Okay, next. Have you played those video games where if the character exits the screen on one side and then it re-enters on the opposite side? Like if it exits the screen on the left, it
Yeah.
re-enters on the right. Or if it exits on top, it re-enters on the bottom. Like Pac-Man's like that. Yeah. Okay, same situation here. If the graph exits the screen on the bottom here, it re-enters on the other side of the asymptote on top. It re-enters here. Yeah. So if the graph exits the screen on the bottom to the right of the asymptote, to the left of the asymptote, it just re-enters on top. It's like Pac-Man, goes down and comes back down this way. Now, we know that here it's got to follow the vertical asymptote. Okay? We know that in the edge, it's got to follow the horizontal asymptote, right? Does it cross the x-axis anywhere here? No. So then it's just that. There is no other way for it to look. It's just that. Because this graph spans, yeah, there's more. There is more. Okay, on the left side, it exits the screen on the top, so then it re-enters on the bottom. Same situation. Gotta follow the asymptote here. Can't cross the x-axis anywhere else. There is no other way for it to look but that. And take a look at that. Who would have thought you would be able to graph, anybody would be able to graph this without a calculator? But look at that. We did a pretty awesome job. Okay? Now, the curvature, how, like how steep, how wide, that, it can't be precise unless you're picking points and plugging them in. I'm not going to make us go that far. However, this general shape is what I need. I need to know that this is curved on the top right, curved on the bottom right. This goes in this direction. What you need to show precisely are the placement of the asymptotes, all of the zeros, all right? And then if there is a test point, show me a test point, okay? We're cool on this? All right, so now we could do another one. Okay, all right, so let's do another one. Can you put your, okay, so let's do one more. I have 12 minutes left. Okay, let's do this. Here.
Is this the last part for this?
Yeah.
Like there's part 2, part 1.
Yeah, this is part 1. Okay, so it's always good practice to factor everything first. So here, I'm going to get x minus, tell me, what?
1 x minus x plus 1 x minus 12.
That's the one. X minus 4, x plus 3. Okay? Here, so this is, I'm going to do an intermediate step here. It's 2x squared minus 4. Is that right?
Mm-hmm.
And then how does that factor? Correct. X minus 2, x plus 2. Okay? All right. So now, for domain, I could go either to this or to the factored one. It's much easier to go to the factored one because I could just see it and I don't have to do any more work. I already did the work there. So what are the points that we need to exclude from here? Plus or minus 2. It's the points where this equals 0.
And we're not using the 2?
No, the 2 is just a factor it divides out. So
okay.
negative 2 and positive 2. So domain is all reals minus plus or minus 2. Okay. Vertical asymptote. Does the x minus 2 cancel with anything on top? No. So x equals 2 is a vertical asymptote. Does the x plus 2 cancel?
No.
So x equals negative 2 is a vertical asymptote. They're not always going to be plus or minus 2. That's just a coincidence. Was that what you were going to ask? No? Okay. Okay. For horizontal asymptote, where do I look? Where are you looking though?
The first one.
The original one. Okay, that's important. Please, 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 that's important. Okay? Okay, so they're the same. So y is going to be, the coefficient here is 1 over 2. And so here we just go to the y equals 1 over 2. Okay? And now let's find the zeros of this guy. Yeah, so zeros, I'm going to set the numerator equal to 0. Now look, I can either set this equal to 0, the original, or the factored one equal to 0.
Well, so then it's x equals 4 negative 3.
Correct. So x equals 4 and negative 3. I love rational functions. Okay, so at 4, there's a 0. At negative 3, there's a 0. Is there a 0 in the center section?
No, man.
No, there is not. Okay, so what happens here then? It's like that. Okay, so here it's going to go like this, right? So on the left side, it looks like this might go like this.
Oh, well, I was thinking. Oh, because, right. So if the 0 is not on the horizontal asymptote, it doesn't cross.
Yeah.
Yeah. Okay, so the thing is, look.
So if the horizontal asymptote is not, well, how do you know if that does not cross the horizontal?
Oh, so how do you know if it's like this or if it's like this?
Or like the other way.
So what you can do, right? What you can do is pick like negative 4. So listen, you could pick a point anywhere here. In fact, you know what? It would have been maybe a wiser choice to pick a point. So let's pick a point. I think I jumped the gun because in my head, I think I just thought ahead because I've been solving this too many times. So let's pick x equals 0 again. Okay? When you have x equals 0, let's plug it into the original function. In the numerator, what do I get? Negative 12. In the denominator, what do I get? Negative 8. So essentially, I get positive 12 over 8, which is what? 4 over 3 over 2. Okay, so I get 3 over 2. That means at f equals 0, this is 1.5 here. Okay, so now let's think about how that looks. That might be enough for us to work with this. 3 over 2 is 1.5. Okay, so at x equals 0, the graph is here. Now I know it's got to follow a vertical asymptote on the left and a vertical asymptote on the right. Is there anywhere in the center section that this is going to cross the x-axis? So what are some ways it's going to look then? If it's going to follow a vertical asymptote on the left and the right, then the way it looks is like this. Okay? Because it's got to follow a vertical asymptote here and a vertical asymptote here. If those are on the bottom, you can't get to the bottom without crossing the x-axis. But there are no zeros here. It's not going to cross the x-axis, so that's how it looks.
Then how do you know about the other?
Okay, the other one. If it exits the graph on top, it must re-enter on the bottom. So that's how it looks.
Yeah, but how do you know
if it exits on top, it's got to re-enter on the bottom, so that's how it looks.
But how do you know if it doesn't cross the horizontal?
If it doesn't have any zeros.
You mean like if it doesn't go that way?
Yeah, why? Do you need to have a 0 on the horizontal asymptote.
No, so what you would have to do is pick points, but most of the time they're just gonna flatten out quickly. Okay? All right, so do you see the logic behind how we do this? Basically, if you find one region, then from there you could alternate to the other regions and find them. Okay? So with this, homework part 1 is due the next time I see you, which is Monday. Now, also on Monday, you're gonna turn in homework, right? And that's gonna be 2.1 part 1, 2.1 part 2, 2.2 part 1. So
only all of part 1.
Yeah.
Yeah.
yeah. So